of all of the activities for the smart factory in the plant. We are the first smart factory in US, and we are the lighthouse as well. For this presentation, I will share with you, all of you, history of industry, Industry 4.0, Internet of Things, Industry 4.0, and Industrial Internet of Things, Mechatronics Engineering in the Industry 4.0, and we have at the very end questions and answers. If you want to take notes about your question, so it will be great during the presentation and just in the final, so you can, or when we finish, you can make your questions to me. I will encourage you to do that in English because it's the purpose of this presentation to have everything in English. First, let's go to start with the history of the industry. So we are in the fourth industrial revolution, but the first industrial revolution started in 1760 with the steam engine. That was the Great Britain. And 1760 was only 7 years before the US or the United States independence. So the United States becomes one of the pioneers about this industrial revolution, while Mexico get the independence until 1821. So I think Mexico was still just looking for the silver and all of the natural resources, but the rest of the world was working already with industrial revolution. Second industrial revolution was in the 80s, or started in the 80s with the mass production. This is when the Ford came with the automakers, the brands, the division of labor, when they start as well with all of these unions for the operators, and the electricity as well. All the plants and factories start to use electricity for the production. The third industrial revolution becomes a couple decades ago, 1960, and most of them in the Silicon Valley in California, with the digital revolution. That was the invention and the invention of the computer and the internet, all this boom of the semiconductors and everything that maybe takes only a couple decades to be completed. So that was not as long than the previous ones, but was still required some time to do it. And the fourth industrial revolution, this term was coined in 2016 by Professor Klaus Schwab. He's the founder and the CEO of the World Economic Forum. So he proposed this. He wrote the whole book about the fourth industrial revolution and what is most of the concepts of this fourth industrial revolution or industry 4.0 are coming from. A technological, and he mentioned this in his book, technological revolution that is blurring the lines between the physical, digital, and biological spheres. So this is a fusion of technologies. The fourth industrial revolution involves all of these different technologies in the same way to get all of the advantage. One of the difference or two difference between the third and the fourth industrial revolution is technology is merging more and more with humans' lives. That means all the technology that is recently or is developed is to focus to humans, how they can interact with that every day or day by day. And second, when the technological change is happening faster than ever. Imagine the telephone, when the invention of the telephone, to get 100 million users, the telephone requires 75 years to get those users. So the Instagram, to get 100 million, Instagram needs 2 years to do it. In the Pokemon Go, 100 million users in 1 month only. So that is how fast the fourth industrial revolution is comparing to the previous third industrial revolution. And this industry, the exponential growth of these technology advances is because this fusion of the technologies. So what we have right now, gene editing, how all of this, for example, the vaccine that is already for the COVID-19. So it's part of this, all of this revolution, machine intelligence, how the algorithms in the, I don't know, when you make a research in YouTube, so the algorithm is looking for what you want to see. The robotics, the 3D printing, that this is fantastic. For example, you can get, I don't know, your hands or something like that. Runners that are doing the Olympics, if you need a leg or something like that, they can print it out using this 3D printing. The nanotechnology for the semiconductors and everything micro that we need in cell phones, for example, and all the smart materials as well that are replacing the kind of steel, for example, is one of those applications. But all of those technologies are merging together in the Industry 4.0. But Industry 4.0 is something in a direct relationship with the Internet of Things. What the Internet of Things means, everything or every object is connected to the network. So imagine that you are in your house. So you have your TV, your computer, your refrigerator, your washer machine, everything is connected to the internet. And all of those objects are sending out information or data to the cloud. So that is the Internet of Things. So connected machines and objects, devices are feeding the fourth industrial revolution. And specialists are predicting that for 2025, in just 10 or 15 years, 75 billion of devices will be connected to the network, sending data out to the cloud. This data will be used for machine learning and artificial intelligence. So we already saw that in another example is the YouTube. YouTube and Google are looking for show you only what you want to see, not how all the information is around. So this has to inconvenience, if you want to say in that way, because they can show you only part of the truth. So it's not the whole reality or the whole information that you want to know. They just focus on what they think that you need to know. So that is kind of the issues. And the last one is the digital transformation. This is pretty important thing because that is what the industry is looking for. So to don't become obsolete, they need to start with this digital transformation. What that means, everything is connected and sending data out to the cloud. That is part of the industrial Internet of Things. In the Industry 4.0, you hear that, I'm pretty sure, for your parents or for the people that you are, when you say to them, I'm a mechatronic engineer, and they ask you what a mechatronics engineer doing, working with robots or something like that. So maybe they told you that you will put a robot to remove an operator or to get a job from a person, right? And this is one of the fears to the machines. A robot will replace a human taking its job. And stewards confirm technologies like artificial intelligence will eliminate some jobs, but it will create demand for new skills that many workers don't have. And keep that sentence in your mind, new skills that many workers don't have, because those skills is what a mechatronic is. I will show you a video. So that robot is unload those boxes from the rack, these gray boxes. So for load centers is what the Schneider is doing. This is a project that I have been working for 3 months. So I launched in this production line already, and it's running actually. So this robot is taking the place of an operator. So before this robot put in place, an operator was manual handling the boxes from the rack to the conveyor. So now we have robots, so we don't have any more kind of human interaction, and we want to say in that way. But kind of I take away the job for this person, but I have a job now in the company to do this. You know what I mean? So this is one of the skills that you needed in this fourth industrial revolution that is right now. So you need to learn all of those skills to be part of that revolution. Back on this robot, there is a wide cabinet. So put attention on that because we will see that in the next slide. So this line is doing this assembly for the load centers. So the robot is putting just the boxes in the conveyor, but they are 15 stations or 15 processes doing kind of the same thing with, well, not everyone is a robot, right? But so there are 15 stations doing the full assembly for the load centers that you can install in your house or in a new construction. And this is just the first operation of that. This is the first station. So it's a pretty big assembly line. And all of this assembly line is controlling by the single PLC. So this robot is talking to the PLC, and the PLC is activating conveyors and everything. Well, you know that about it. So this is the cabinet that I was talking about that was back in the robot. So this is a brand new. They have 2 or 3 months just with us in the plant. As you can see, there is a window to see inside in the cabinet. That is the PLC rack, basically. And this is an HMI in the right side. That is the to how you control, well, the stops, alarms, go to manual, go to auto. So this is the human interface. And this is internal, how brand new control panel looks like. And you will be very familiar with this because I think you are working with this with Dr. Alonso in the drivers or controlling all the drivers for your projects. So those are the drivers that we are using for the conveyors, are Schneider Electric drivers. And one of the things that you need to know is how, for example, how to select drivers. If you are launching a new project, a new line, you need to know what kind of drivers you want to use and how those drivers works, because there are tons of configurations that you can do it. And especially when you know how those works, you will be pretty good in troubleshooting. That is one of the things that people will call you as well in the industry. So maintenance can put the hands on, or manufacturing engineers can try to resolve the issue, but you will be the expert. You will be the expert, the control expert for the plant. So keep that in mind. That is why you need to know how that works. This is the PLC. This is the new generation of Schneider Electric PLCs. As you see, or I was talking about, this is a huge assembly line. This is a 15 stations, a lot of conveyors, a lot of sensors, cameras, vision inspections. So a lot of data and devices are connected to this PLC. But as you see, let me show you how a rack, this is calling a PLC rack over here. So this is the end of that rack. So it's nothing more to the right side. Here is the 24 volts for the rack. Here is your PLC. Here is your Ethernet card, one input card and one output card. There is another Ethernet card here. But imagine that you have all of this massive assembly line with only few cards connected to the PLC. So that maybe those classes with the PLC that you have a bunch of cables activated, coils, inputs, outputs. So with the Ethernet communication, I think that maybe pass away almost. So, and keep in mind this last card here, because we were talking about that in a future. So for this PLC that is a brand new PLC, I need to talk with an old PLC that is in the other side of the plant. So to walk from this station to the other assembly line that I was talking about, take me maybe 10 minutes just to walk to the station. So, and the other PLC is 20 or 30 years old. So it's pretty old PLC, but I need to talk and send information to that PLC. So how is pretty complex, well, expensive. First, to get a cable from this cabinet and just write the cable for the other side of the plant. There is a lot of money just in copper to spend on that. So instead of that, I use this extra card here. That is an Ethernet card to talk with that PLC. So that is all my signals will pass through this card and the PLC receptor. So he will get all the signals as well, just using the Ethernet communication. So now I'm using two because I have two networks. So one is the private network for the PLC itself, that is the production line. And this is the second Ethernet card to join the plant network. So you need to know that because you will use it when you jump to the industry. So keep that on mind. And this is my PLC program. This is basically how the structure is working. This is the software, the Schneider Electric software. And you see in your left side and your right side, well, your right side is all the logic that you can create it. And this is the structural view. You change to the project view, you will see all the stations that I have here. As I mentioned before, they are 15 stations. Every one has its own logic to do all the things. You have indicators, modes, auto, manual conditions. You have all of the code for your robot. Excuse me. You have how you activate the cylinders outputs, and you have the main sequence as well to follow all the operations that you want the station to do it. So you should be pretty good to write down this logic. They take several time to learn. But over here, those 15 stations needs to talk with the PLC without cables. And over here, that PLC rack that you see in the previous picture and the previous image is over here. So you will see the inputs card, well, the PC, the CPU, sorry, the input and output, and the two Ethernet cards with the new one that I just added. So that is your rack configuration in the PLC. So that little PLC that is really powerful is talking to every device in the production line. And this is just talking with using the Ethernet network. I will show you over here. You can have 255 devices talking to. So you can see here, this is your IP address, and you will start with your private network. And the left side, all of those here, those are the drivers that I'll show you in the picture. Then you have the Yasukawa robot, you have the DM Taraman, that are the Cognex barcode readers. Everyone is just sending communication or sending their data out to the PLC using the Ethernet. As well, we have here all the Cognex, the vision systems. So all the cameras are sending out the information as well using the Ethernet. This is a IOI robot, that is a 3-axis robot. As well, with just the communication with that, we have a ChemNots deep rack, ChemNots drivers. So all of that configuration in the line is using just an IP address. So there are no cables between them. Well, the Ethernet cable, right? And this is the new one at the very bottom. So you see this IP address is different than this one because this is try to talk to the main network in the plant. Kind of tricky part of how you can get all of this information. I'm pretty sure you will use You will use all of these when you jump to the industry that you are pretty close to do it. So keep in mind, and if you don't know how to do it, you can watch this video again in some place somewhere, and maybe that can help you. Most of the PLCs are pretty similar. I mean, the logic is pretty similar. The software and is pretty different, and the kind of maybe the logic and the functions are pretty different too. So just keep that in mind. But this is part of the mechatronics that we are using. So we have all of the power electronics in the control panel. So we get the integration in the PLC, how the PLC is talking to every device, and we have maybe you are doing this in your classes, the vision systems and how you process all the information. So this is my laptop. I was doing a vision system program to inspect a component. Well, it's a subassembly, and that dark or black square is enclosure environment for the cameras, because you need the special lights as well, so they don't like to work with the regular lights. And this is what is the program is looking for. Do you remember the boxes working, or the robot was working with the boxes? So here is the box. And this program can detect the color, if it's a gray or it's a white box, can detect the white and the length about it. So it can say, or it detect automatically what kind of box is. So we define box ID. We have 150 different boxes in the plant, and this vision system can detect every box at the beginning of the station. So the operator doesn't need to do nothing. This is an auto process. And as well, all of this is detecting paths in every different kind of type of box. So kind of those holes that are here. So this program is able to detect it. But what becomes a smart factory? So this is the smart factory structure that we have. Well, every plant in the world is a standardization of how you become a smart factory plant. We have the connected products, all of the devices that I show you, the robot, the vision systems, the sensors, the barcode scanners. So everything is connected to the Internet of Things. And then you have your edge control. So that can be your PLC, or that can be an industrial PC that is sending out the information to the cloud. The cloud, well, can be a cloud, can be your server, the way that you are saving all of that data. And over here, after that, you have your apps and analytics and services. This is your software that is analyzing all of that data that you're sending out. This is where the artificial intelligence is working on, and all of those algorithms and predictions and everything is taking place. Then that is all of that information is sending out to the building, data centers, industry, this smart city, depends your application that you want to. And that becomes kind of this data. So this is coming from the line that I just showed you. So all of this data giving you how many parts are producing per minute, and downtime that you have, your KEs, a lot of data, your target, if you are explaining the downtime or not. And this is a real-time data, so you don't need to wait until tomorrow to get the analysis about your production, if it was good or was bad, how your numbers was. So this is a lab data. You see kind of over here, for example, this red bar here means the line was down for a long time. So everyone can see that. So if you have some issues in your production line, somebody will come to ask you questions like, why is the robot not doing the job, or something like that. So this is an application in the industry, that you have the mechatronics in your robots and your technology and your equipment integration. You have the industry 401 and the industrial Internet of Things working together. So that is, you will be a part of all of this movement very soon when you jump to the industry. And I think kind of the question is not like when the fourth industrial revolution happens or will happen. So it's already here, and you need to learn all of these things because you will need it. So I'm pretty sure, very close in the incoming couple of years, all of the plants in Mexico and every country, they will start to look to implement these kind of things to be a smart factory, because it's part of the energy savings, CO2 to the global issues that we have already. Um, so you can be one of the engineers in charge of that. Well, thank you. Thank you for the opportunity to let me make this presentation for you. I'm pretty glad and I'm happy to help a little bit with my alma mater to share all of this information and the experience. So maybe this is summarized in just 30 or 40 minutes, the presentation. But trust me, when you are working in these kind of projects, that will take you 3 or 4, at least 6 months just for the conception, plus the implementation, well, the launching and the start of production. So it's kind of projects that takes 9 to 12 months just to make it. And plus the smart factory, so it's another time too. So you want to contact me or to add me to your network, this is very important. You need to use LinkedIn. If you don't have an account with LinkedIn, all the recruiters are looking in that platform. So if you want to contact me for some questions, so that is a way that you can do it. So, and you want to add me to your network as well, so you're very welcome to do it. And the right side, there is this video will be posted in my YouTube channel. I have a channel that involves a little bit of technology, but is more about traveling. So I have a little bit more than a year doing this, well, traveling with my channel, but I will post this video as well. So you, for future reference, you want to watch again or to share with a friend, the video will be in my channel too. And I think we start with the questions here. Thank you again.
Yeah, thank you, Luis. Well, we start with the question section. Do you have any question? Anybody?
Yeah, I have a question. And my question is, what difficulties did you get in your path to the professional field or to get the position that you have today?
Yeah, thank you for sharing, Ulises. That is a big question because, well, I have 10 years working in the industry already. Uh, and one of the things I think, well, at the beginning when you try to learn all of these skills, programming, integration, new the technologies, especially because we are limited in how we learn in the college because we don't have obviously all the technology available. Uh, but I think one of the barriers was the language. So 6 years ago that I came to US, so my English was not in this way that I just talking to you, to all you today. So when I came to US, maybe I have 20% of English and that's it. So it was pretty basic. I mean, just to take an exam and pass it. But when you need it every day and you need to talk every day with people, so that is not enough. Well, especially when I start with my Master of Science. So I just have 6 months in US and I didn't sleep. I didn't sleep for 2 years uh, to accomplish all of the publications for the Master of Science, and I was working full time as well. So I get to sleep maybe 2 a.m. and wake up at 5. And that was one of the hardest parts or my career, just the language or to learn a second language. And the other one is just work every day to get experience, especially in programming and integration. You you learn every day. I mean, I have 10 years and there are some things for the integration that I don't know how to do it. And every project is a new challenge because you can you can know everything. I hope I answered your questions in the right way.
Yeah, thank you.
Okay, guys, another question. You can raise your hand in
I do.
your screen.
Uh, did you did you get any capacitation once you get hired?
Thank you for sharing, Daniel. Yes and not, depends. I think depends. Every company is different. When I when I was working in my first jobs in Mexico, I was working in the aerospace industry at the beginning, and I was working as quality engineer, so I never get a training about it. For my second job, I work in Querétaro as well, part of the automotive industry infotainment, and I didn't get any training neither. That was part of the manufacturing. I was working as manufacturing engineer. Uh, then I moved to the automotive, like the big automotive industry with a Japanese with a Japanese company in Querétaro, and they sent me out to work in Japan. I was working in Japan, living for in Japan for a little bit more than 3 months, and I get not the best training, but I get something over there, and that was I think most of the training that I get in my career. The most of them was working with people. For example, integration. You have a Cognex brand. Always use the customer service. Call them all day. You need it because that is how you will learn. And something that I learned from coworkers, especially with a Japanese guy or Japanese engineer. He showed me a lot, but you need to, I will say this in Spanish. Necesitas acercarte a la sombra de un buen árbol. You need to learn from somebody that is pretty good, uh, at least a year or something like that when you are in your beginning as engineer, because when you get out of college, um, we think that we know everything, but it's not true in the industry. You need to know about the process. You need to about uh, what quality means for the assemblies. You need about how to make a PFMEA. So all of that things you never see that in college. I mean, or the skills and everything for the how we can say it, academic perspective. So you will get it, but in the industry is a little bit tricky and different. So at the beginning, I will recommend that to you. So you need to learn from somebody that is really good. So just found it and invite him to the lunch or something like that, or bring some coffee in the morning. Just get friends, and this is part to build your network. That is very important. You need to build a network because when you get a job in the industry, you need to work with people. I mean, you have your team, and if you are a part of the team, if you want to jump to the leader to be the leader of the team, so you need to make that people to work together. So in the real life, you never work by yourself. Well, you do the things by yourself, but it's you know you need we call it cross-functional team. So you need to work with a cross-functional team all the time. So and this is part of to build your network.
And what about your past job? Did you get them by LinkedIn?
Sorry, how was that?
I was talking about your past jobs. So did all your past jobs you got I mean, in Querétaro, and I don't remember the other ones, but did you get them using the app LinkedIn?
Yeah, and the recruiters are looking for you all the time. I mean, when I was in Querétaro and I changed jobs, when I started to work with the Japanese guys or the Japanese company, I'm sorry, you can change your state in LinkedIn. So you are able or close to offers. So when I'm working with a company and I'm good with the company, I always change that to close, or I'm not open for a job positions or something like that. So I came to US, and 2 years ago that I have 2 years working with a Schneider. So I just changed the switch or that section in LinkedIn to open to possible opportunities. They contact me in 2 weeks, I guess, and I just moved to a Schneider. So it's pretty robust platform. You want to get a job, but you need to work. You need to work in your resume, your curriculum. So you need to do a really good one, because when you get an interview or a job interview and you are looking for a position, you are or the competition is pretty hard. I mean, it's Celaya Institute of ITC. You have the Tec de Monterrey, VM, Politécnico, UNAM, blah blah blah. If you go to another country, you have Georgia Tech, Massachusetts Tech, Virginia Tech, and all of the states, Stanford, blah blah blah. So you are playing in the grandes ligas, as we say. So it's pretty important that you build a strong curriculum and a strong resume, plus your network. So if you can look at me what I have in LinkedIn and maybe try to make a copy of that. But in the same way, I went to the one of the curriculums in the Boston, in the Massachusetts, and used that as a base. I mean, why not? Obviously, you need to be honest in where you put right your skills, but at least to have the structure of that, because you will compete with a lot of people in different universities. Keep that in mind, especially and when you are in the industry, those guys will come to speak in French and English. So, and you need to be competitive if you want to grow up. You need to know how to sell pineapples, as we say in Spanish.
Gotcha.
Okay, thank you very much, Daniel.
Yeah.
Thank you very much, Luis. Brian, your question, please.
Yeah. Hello, my name is Brian. First of all, I would
Hi,
like
Brian.
to thank you for sharing your time and experience with us. And my question is, in your opinion, what skills will be more important that students dominate for be part of the IoT revolutions?
Thank you for sharing, Brian. Good question. I think one of the things that you need to develop in college, in your career, is your logic. Your logic. I remember one of the classes that I took was the ensamblador language. Is that the right name? That is kind of the pretty basic, and looks like old programming, but that for me was pretty good to learn how to do the programming in a PLC. So for that part, one of the things that you need to be present is how programming in the PLC, because you will need a PLC in every place, and then be open to new technologies. I mean, not only the PLC, you will use Aviva, that is RODNet, not RED. You will use LabVIEW as well. So is everything that you can imagine, you shall be able to apply it. And for this one is try to disconnect for the cables as well. So thinking about everything or the communication shall be between Ethernet, and you need to send data out to the cloud. That is the key point. So we want right now that the project that I was just talking a little bit about it, so the communication, I sending or I working to send all of the faults or the fault codes in a production line, air pressure, power, the line was down, the operator is not at the station, material shortage, ground components, all of the faults that you can imagine, like talking about like 100, 150 faults or alarms in the station and the production line. I collecting all of that data in automatic and send it out to the cloud, and then get the data. Well, I don't do it, right? But we have a software that is doing that already. So get the data and show them in that screen that I show you, kind of with the bars. Well, this is just a part of the screen, so it's a big screen with more information about it. So you collect all of that data and you display that. So and okay, you get this red bar. The question is why you get that red bar. So in automatic, you get the answer for that. Okay, the robot is starved, or the power shortage, something like that. So you need to think in that way. You will send all the data. You will collect all the data, send it out to the cloud, and use that data to make solutions, to improve your process, to improve your life, to improve your city, to improve energy savings. You have an oven, how you improve the electricity or the energy consumption. So all of that is part of this revolution, and this is one of the things that you need to think about it. The integration will be little different now than before. 10 years ago, when I started in the industry, the smart factory was just a concept. No, doesn't exist yet. So, and when I was working, all the PLCs was, a bunch of cables, a lot of inputs and outputs cards, kind of 3 racks in the PLC just to handling all of those input cards. I show you how the rack is now in the PLC. It's just one input card, one output card. The rest of them is just Ethernet. Well, in your programming inside in the PLC, right? You are getting all of those inputs and outputs, but in a digital world. So now in the wiring with the cables, all of those signals are digital now. And this is, you will hear a lot of that in the company that you start to work soon. You will hear about that digital changing or digital transformation, because it will happen in every company pretty soon.
Okay, thank you.
Thank you, Ryan.
Thank you. Luis Eduardo, your question, please.
Okay. Hi, first of all, sorry for the camera, but my connection right now is not able to handle the transmission. Well, about my question, I would like to know about your forward-looking, the way you express yourself, how you got to the US and all like that. Well, overall, I would like to know where do you see yourself in a couple of years?
Thank you, Luis. Thank you for sharing. Well, the way that I moved to US was a little bit longer. I have 4 siblings. I talked about this in last year in a congress. Dr. Alonso invited me to be a present about the Internet of Things. There is a video as well in the channel if you want to watch it. It's pretty good. But I have 4 siblings, and the oldest one moved to US long time ago. I talking about maybe 25, 26 years ago, maybe 30. And he become a citizen. At that point, he had married with a lady and with a girl, and he become resident and then citizen, and then he applied for my parents to become residents as well. So I was in high school, maybe 3rd semester, when my parents started with the process for me and for my little brother to become a resident of US as well. But I never kind of stopped my education or something like that. I was pretty sure that the way to grow up for me was with the education. I was living in a tiny town, El Sabino, in Guanajuato, close to Salvatierra, and it's a rural town. A lot of uh, poor people, because this is catalog or for the town, and I didn't have too many options or how to move away from that. So I never keep up about the education. So I continued with my education, and when I was in my last year in college in El Tecno, I get my resident card. So I was able to travel to US. One of those travels, so I was working in the cornfields, sorry, just doing the manual job with a pala. But I meet good people to create a network, and I get my internships in Mountain View, California. That is the Silicon Valley. We were making prototypes or doing the chambers. There is a kind of chamber for the new processors, the MAD, the Intel. So all of those chips, when they are running before to put in the market, they need to, well, or all the tests that they need to pass, there are chambers because those get really hot. So we made all of those chambers to cool them down. I was doing my internships over there, but when I came back to get my title in Mexico, I was trying to move to US. After that, well, I get my title, right? And I spent maybe 3 or 4 months looking for a job. I didn't get it. I get a couple interviews in Atlanta, Georgia, and I decided just to come back to Mexico. I start to work in Querétaro, and then I get this kind of temporary assignment in Japan, and I start with my network with the other people that went to the same training with me. So one of those guys was an engineer from Kentucky, in US. We get a good relationship, and he shared the contact of the human resources or in the headquarters. So I spent a lot of time making my curriculum looks good, and finally I get an interview with those guys, and I don't know, maybe I just smile and that's it, and I get my transfer to US. And then when I arrived to US, I was working for a couple of years, get my for a couple months, and after 6 months, so I realized that like I came to US with a title from a foreign country. So the competition is with the state universities here, plus the big techs in the country, Georgia Tech, Virginia Tech, the guys in the MITs, that the MITs are almost going to the corporative positions. So they know how to sell pineapples. But anyway, my title was from Mexico, right? And I was honest with myself. I know the same things than the than another engineer in US. I mean, we use the same books. The education is good in Mexico. But for the HR perspective in an interview, you have a title or an engineer with a title from Mexico that maybe you never hear about the college, and you have another engineer with a title from Georgia Tech. So the decision is pretty simple, right? So after that, I decided to start with my Master of Science over here in applied engineering, and after get my degree, so is you will get a job in the top of the Georgia Tech guys. So that is kind of my little, I resume maybe 10 years of my life just in that couple minutes. Yeah, but that is Luis, and I will share something that I learned in my first visit to US. I was working 3 or 4 weeks doing the landscaping, cortando la yarda, like the other paisanos call it. And one of the guys or the owners of the houses that we call it the backyard uh, was a French engineer that he was working with Caterpillar, the construction, the big machines that they made for the construction part. So, and my friend told me about like he's an engineer and he came from France, and maybe if you want to come to US, you can ask him how he got it. It's like, yeah, let's go to it. So we're in the front door, and when he came out, the first thing like he told us was like, you want to talk in English and French or in Spanish? It's like, well, you can do it in Spanish, will be better for me. And we were talking a lot. He came to US doing because to get a Master of Science as well, but he came with a school, with a kind of just as a student here for the graduate school. But at the very end of the conversation, he told me, necesitas apuntar tus sueños hacia la luna. Y si no llegas a la luna, ya estás en las estrellas. And I don't know, but I remember that phrase that French engineer told me that day. And I think as us as Mexicans, I think we need to believe in ourselves. One of the questions in the last conference, or in the last Congress, one of the students make a question like, how, if I in a competition, a robotic competitions against other schools or the universities in Mexico, what advice you can give me about it or something like that. And so like, well, just trust in yourself. Is that you need.
Thank you very much.
Thank you, Luis.
Thank you. Last question, please, Daniel. Yes or no?
Yeah, can you hear me right now?
Yes, Daniel, we
Sorry,
can
my
hear you.
internet is kind of lame. Okay, I was wondering, I'm actually studying Japanese at this time, so I was wondering, how do you feel the environment when you get to work over there?
Thank you for sharing. This is a good question, and I will tell you something. El león no es como lo pintan. The Japanese people, when they go out to Japan or they come to US or to Mexico to work, they make sure the perception that we have the perception of them that they are super smart and super intelligent, and that is not true. They are dedicated. I mean, if you are pretty intelligent and you need 1 or 2 hours to get a test or an exam and to get the 10, so if they are not that smarter, they need 5 or 6 hours to get the 10 as well. So they never give up. They will spend the 6 hours to get the same thing that you get in 2. That is the difference, but they never told you that. About the environment, I was working well together, one by one, with the Japanese engineers, and this is how I know it, and I got it. Like, they are not smart or intelligent. It's just as regular. I mean, they are pretty smart people and they are pretty stupid people. So it's like every country, right? The education is the same as us,
Yeah.
but something like you can be same that Mexico is the hours. You will be working same 55 to 60 hours per week in Japan. I didn't like that. With the same salary, I mean, you work a lot of time just for free. That is not a deal. Doesn't matter if you're in Mexico and Japan and US in Germany, you need to get money for your job. But one of the good things is like violence, all of these, for example, the criminal things. So that doesn't happen over there. There is a lot of respect about it. But about the culture, I think that remembers me a lot to my hometown. Well, by the old days when my grandpas are living. Kind of, we were in a stadium in a soccer game in the Japanese league, uh, and we were, get the gloves and all of these things and make a lot of mess in las gradas, in the seats. But when the game was over, everyone take the trash or start to take its own trash. So they didn't pay for somebody to come to the stadium to clean it up. Those kind of things are in shock, but you can translate that to your job. And this is one of the things that I learned from them. The programming part, but talking about the programming the management. Sorry, program management. So we as Mexicans, there is a big issue that you can make a plan for more than 3 weeks. If you want to make a plan for 6 months in ahead, kind of, if somebody told you like what you will do December 18, you will say, I don't know, it's just May. So you as a Japanese guy, what you will do in December 18, I'm pretty sure they will give you an answer for that. So that is pretty, if you apply that to your profession, as you're a professional, this is a pretty good skill, because if you're launching projects, if you are in charge of new projects, you need to make all of that planning for 6, 8, 9 months in ahead, or a year in advance, and have all of this planning for, every month. I need all of those activities until you complete your project. So this is a pretty hard to understand for us as Mexicans. But there is a bunch of skills that you can learn from them, absolutely. And there is another skills that you don't want to learn from them, but is good as well. But I
All right. Thank you. Appreciate it.
Okay, guys, we
anytime.
close the question section, and I want to thank you to Luis for the talk, and to yours to link to this conference. Thank you very much. And Luis, you have I don't know, some other words to the students.
I would like to say just, well, thank you first for sharing your questions. Don't be shy about it. I mean, just do it. Uh, but trust in yourself, and trust that you have enough skills to go outside and be competitive with every college, with every student from other university. Just do your job. I mean, spend your time doing a good curriculum, um, doing a good presentation, do a good job interview, be prepared for that, and you can be pretty soon over here. I was 10 years ago, I was taking classes, same as you, in the classrooms in Celaya. So, and I never imagined that I will go to Japan to work over there, and I was working in United States in a smart factory, and less I would be in charge of that. Uh, but dreams are always possible. We just never give up.
Thank you very much, Luis. And well, we finished the conference. Thank you very much to all, and have a nice day.
Thank you, everyone.